Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over problems 6 to 10 of the August 2016 Geometry Common Core Regents exam. Alright, let's take a look at question number 6. It reads, in triangle ABC, where angle C is a right angle, cosine A is root 21 over 5. Question, what is sine B? Now, before we go into the identity we're going to be using to solve this problem, let's see what the relationship is between angle A and angle B. Okay, so we're told that we have a right triangle ABC, and the right triangle is angle C. Okay, all right. So the other two angles are going to be A and B, or acute angles. So let's call this angle A and this angle B. Now, what is the relationship between angles A and B? Now, let's go ahead and establish that. If you add angle A and B and C together, based on the triangle angle sum theorem, we know that the sum is going to be 180. But since angle C is 90 degrees, we can carry out that substitution and have angle A plus B plus 90 degrees being equal to 180. Now, if we subtract 90 degrees from both sides, what do we find out? What is the relationship between A and B? So we have A plus B equals 180 minus 90, 90 degrees. So we can clearly see that angle A and angle B are what? Angle A and B are complementary angles. Okay? So there's a special identity that applies to complementary angles, and that's known as the cofunction identity. Okay? So let's recollect what the cofunction identities are. I'm going to present them in verbal and symbolic form so you can really understand what's going on. Alright, so what are the cofunction identities? Well, all that it simply says is that if two angles are complementary, then the sine of one is going to be equal to the cosine of the other. Okay, so if two angles are complementary, what does complementary mean again? It means that they add up to 90 as indicated here. Then the sine of one angle out of the two is going to be equal to the cosine of the other. Okay? Alright. In symbolic notation, what we're saying here is, let's say A and B are complementary, so they add up to 90 degrees. So if A plus B is equal to 90 degrees, then we have two possible equations. Sine A is equal to cosine B, or you can say cosine A is equal to sine B. Okay, any of these two equations hold. These are your cofunction identities here, as long as the angles are complementary. So let's solve this particular problem. Let's apply the cofunction identities here. We know that cosine A is root 21 over 5. And then we're to find what sine B is. Okay, we don't know what sine B is. So we know that they're complementary, as we established in this triangle right here. So we're going to apply the cofunction identity here. Okay, so cosine A is going to be equal to sine B using the cofunction identities. Okay, and then cosine A is root 21 over 5. If we make that substitution, cosine A is root 21 over 5. Then we automatically know what sine B is. Sine B is going to be root 21 over 5 also. Okay, so our answer for number 6 is option number 1. All right, let's take a look at question 7. It says quadrilateral ABCD with diagonals AC and BD is shown in the diagram below. Question: which information is not enough to prove ABCD is a parallelogram? Okay, so want to pay attention to the fact that we're looking for which one does not meet the criteria to conclude that this quadrilateral is a parallelogram. So before we answer the question, we're going to go over the 5 ways we can conclude that um, a quadrilateral is a parallelogram. Okay, so this is a real quick reminder. Okay, reminder on how to prove, how to show, or prove that a quadrilateral is a parallelogram. Okay, so let's go over the 5 ways and then see which ones are applicable to the options that we have here. Number 1, if both diagonals bisect each other. Okay, so both diagonals bisect each other, then that quadrilateral is a parallelogram. That's this particular number here, 1, is not applicable here because there isn't any indication as to how these diagonals bisect each other. Okay. Option 2, if both pairs of opposite sides are congruent. Okay, both pairs of opposite sides are congruent, then that's automatically a parallelogram. Okay, and then number 3, if both pairs of opposite sides are parallel. If both pairs of opposite sides are parallel, then we have a parallelogram. Number 4, if both pairs of opposite angles, in this case, both pairs of opposite angles are congruent, then guess what? We have a parallelogram. Number 5, if one pair of opposite sides, are parallel and congruent, guess what? That quadrilateral is also a parallelogram. Okay, so these are the 5 ways you can prove that a quadrilateral is a parallelogram. Now let's see which one is applicable to the options here and which ones do not apply. Option number 1, it says that side AB is congruent to side CD, and side AB is parallel to side DC. So AB is congruent to CD, and DC is parallel to AB. So here we have one pair of parallel sides that are parallel and congruent. Is that sufficient to prove that this quadrilateral is a parallelogram? Look at these options 1 to 5. Does this fit any of these descriptions? The answer is absolutely. It fits number 5. One pair of opposite sides are parallel and congruent. That's what we have here. So option 1 is not the answer because the information there is enough to prove that it is a parallelogram. Number 2, AB is congruent to CD, so this is congruent to that. BC is congruent to DA. So we have both pairs of opposite sides being congruent. Is that enough to prove that it is a parallelogram? The answer is absolutely. It matches with option 2. Both pairs of opposite sides are congruent. Based on that, we know this is a parallelogram. You have enough information there. Now let's keep on to number 3. AB is congruent to CD, so this opposite sides are congruent. And then BC is parallel to AD. Is this enough to prove that this quadrilateral is a parallelogram? The answer is no. Okay, you have one pair of opposite sides that are congruent, and then on the other pair that's parallel. That's not enough to show that a quadrilateral is a parallelogram. Okay, it doesn't fit any of these descriptions. Now, can you think of a counterexample? Can you think of a quadrilateral where you have one pair of opposite sides being congruent and the other side being parallel, and it's not a parallelogram? Think about an isosceles trapezoid. What's the story there? Let's consider that. If you have an isosceles trapezoid, what you have is a situation where one pair of opposite sides are congruent and then the other pair of opposite sides are parallel. This is not a parallelogram. Okay, this is an isosceles trapezoid. And that's a counterexample for you to show that if you have one pair of opposite sides that are parallel and the other congruent, is not a parallelogram. Okay, it's not always, it's not enough to prove that is a parallelogram. Okay, let's take a look at number 4. AB is congruent to DC, so opposite sides are congruent here. So this is congruent to that, and then BC is congruent to AD. So if both pairs of opposite sides are congruent, is that sufficient to conclude that the quadrilateral is a parallelogram? Absolutely. Look at 1 to 5. Can you see which one it matches? It matches the third option, option number 3. Okay, both pairs of opposite sides are parallel. Oh, I didn't mark it correctly, sorry. So it says both pairs of opposite sides are parallel, so we're supposed to mark it like this. This is parallel to that, and that side right there is parallel to that side like that. So this is a parallelogram. That's good. Okay. All right. Let's take a look at question 8. It says an equilateral triangle has sides of length 20. To the nearest tenth or 1 decimal place, what is the height of the equilateral triangle? So let's go ahead and sketch an equilateral triangle. So what is an equilateral triangle? It's a triangle where all the sides have the same measure. Okay, so this is 20, 20, 20. So we're asked to find the height. So the height is the distance from the midpoint of one side to the vertex, the perpendicular distance from one side, the midpoint of one side to the vertex opposite it. Okay, so if we look at this perpendicular distance right here, that's the height of our equilateral triangle. Okay, perpendicular distance from a base to the vertex opposite the base. It doesn't have to be at the midpoint. But since we have an equilateral triangle, guess what happens? This altitude right here bisects these two sides. Okay, that's one of the properties of equilateral triangles. So if it bisects it, we have 10 here. This is 10. And this is 10. So we can now create a new problem. We can extract one of these right triangles and we can solve it using a theorem. Okay, so what theorem is that? So let's extract our right triangle. Let's call the altitude h. We don't know what it is. This is 10 and this is 20. Now, how do you find the third side of a right triangle? You use the Pythagorean theorem, right? So what's the Pythagorean theorem? Formula. The Pythagorean theorem is as follows. It tells you that if you find the sum of the squares of the legs, a squared plus b squared, that's going to give you the square of the hypotenuse. Alrighty? So, how do you label your right triangle in order to accurately apply the Pythagorean theorem? Remember, the longest side C is always the hypotenuse, okay? And then the legs are A and B in whichever order you like. It doesn't really matter. So if we substitute these values into our Pythagorean theorem, we should be able to solve for h. So a squared is going to be h squared plus b squared is 10 squared equals c squared, which is 20 squared. Now we have an algebraic equation that we can solve for our unknown, which is h. So let's simplify it. H squared plus 10 squared is 100 equals 20 squared, which is 400. So we subtract 100 from both sides. And then we have h squared is equal to 300. And then we take the square root of both sides to get h isolated. So since we're asked to round, we are going to have to use our calculators to finish off this problem. So let's calculate what that is. We're looking for the square root of 300. Square root of 300 is 17.3205. But we are asked to round to the nearest tenth or one decimal place. So we're going to put our line here. Look at the number to the right of it. Is it 5 or greater? If not, we're just going to round down, okay? So our answer h to one decimal place to the nearest tenth is 17.3. Answer is option number 3. All right, let's take a look at number 9. It says given triangle AEC, so we have triangle AEC right here, and triangle DEF, and FE being perpendicular to CE. Okay, so this is a 90-degree angle here. What is a correct sequence of similarity transformations that show that these two triangles are similar? Okay, so what you see happening here is, first of all, so we're going from, let's say this is 1 right here, 1 to 2. What you notice is the first transformation, let's call it T1, is a rotation. Okay, so triangle 1 is rotated how? Is rotated 90 degrees in this direction. Okay, so 90 degrees rotation in that direction is counterclockwise. 90 degrees counterclockwise. Okay, after you carry out that counterclockwise transformation, your triangle 1 is going to look just like this. Okay, but what is done to the dimensions of triangle 1 in order to make it as big as triangle 2, DEF? This side 4 becomes 8, 3 becomes 6. What does that automatically tell you? It is dilated by a factor of 2. Okay, so the second transformation is a dilation by a scale factor of 2. Okay, so you rotate and then dilate and then you get the triangle DEF. Alright, so if you look at your options, it's easy to see that the correct answer is option number 4. Alright, let's take a look at question 10. It says in the diagram of right triangle ABC, CD intersects hypotenuse AB at D. If AD is equal to 4 and DB is equal to 6, which length of AC makes CD perpendicular to AB? So with this construction we have here, what we have, in order for this to be perpendicular, we have three right triangles here. They all have to be similar to each other. Okay? But in this particular problem, we're going to be focusing our attention on the smallest triangle and the biggest one. Okay? And we'll be using our similarity ratios to set up a ratio a proportion that will solve to get what the measure of AC must be in order for CD to be perpendicular to AB. Okay, so if we break up the triangles, there are three of them, but I'm just focusing on the smallest one and the biggest one. So this is the smallest one right here. This triangle right here is equivalent to this one. And then the entire triangle, this big triangle right here, is equivalent to this one. I just flipped it and rotated it around. Okay? So let's keep that in mind. Now we're trying to show that we want to make sure that this line is going to be, this segment is perpendicular to this base. So if that's the case, this must be 90 degrees, okay? So we have the 90 degrees over here. Now, what we're going to do is use our similarity ratios to set up some proportions, okay? Now, let me just put in some alphabets here. Maybe that might help you visualize what's going on. We have D, we have A, and we have C. That's for the small one. And then for the big one, this is C. We see the 90 degrees right there. And then this is the shortest side, so this becomes A. And then that's B right there. Okay? All right. So let's see if we can set up some a proportion. Okay? So DA corresponds to CA. Remember, these two triangles are similar. Okay, so DAC is triangle DAC is similar to triangle CAB. Now, what's the measure of DA? It's 4. Okay, and what's the measure of CA? The measure of CA, let's just call it X. Okay, and then what's the measure of AB? AB is the hypotenuse of the big one, right? So AB is 4 plus 6, which is 10. And then CA is X. Now, why am I picking on CA? I'm picking on CA because that's what we're looking for, okay? So let's go ahead and set up a proportion statement. We have, from the small triangle, 4, the shortest side over the hypotenuse, 4 over x. Okay, since these two are similar, what corresponds to the shortest side and the big one? It's x, right? Is equal to x over the hypotenuse, which is 10. Now there's a formula you can use to set this up, but I think it's really important to understand what's going on so that in case you forget the formula, you can always break it up and then set up the proportion with ease, okay? Now to solve this, we'll simply cross multiply bottom left, top right, bottom right, top left. That gives us 4 times 10 equals x squared. Okay? So x squared is 4 times 10, which is 40. To get x by itself, we will take the square root of both sides. So x squared is x is equal to root 40. So let's simplify that. So when we're breaking this down, we're going to use a factor tree. Let's extract prime factors. Take out 2, we have 20. Take out another 2, we have 10. Take out another 2, we have 5. So any factors that repeat, we root that repetition of the factor to get just one of them. So 2 times 2 is 4. What is the square root of 2 times 2? The square root of 2 times 2 is 4. I'm sorry, it's 2. Anyway, so this is 2 right here. So these two 2's can break out, but these ones do not repeat, so they stay behind. Alrighty? So this is going to be 2, which is the square root of 2 times 2 root 2 times 5. What's remainder? Okay, the ones that didn't have partners to break out with. So it's going to be 2 root 10. Answer to question number 10 is option number 2. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions about what we just covered in this presentation or any um, geometry concepts on the Regent exam in general, just place your questions in the comment section below, and we'll be more than glad to support you. We always update videos to our YouTube page on a consistent basis. So for updates to the uploads, just subscribe to our channel so you can get notifications in a timely manner. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.